Have you ever typed something into an AI like ChatGPT and just wondered, what is actually going on in there? It feels like magic, right? Well, it's not magic, but it is an absolutely fascinating story. We're going to pull back the curtain and demystify the tech that powers the world's smartest chatbots. It really all boils down to this one question. How does an AI take a simple prompt from you and spin it into something totally new? How does it get context and creativity and even nuance? Well, to figure that out, we actually have to go back in time to when computers, well, they were pretty bad at remembering things. No, seriously. The first huge hurdle in building a smart AI was its terrible memory. See, early models just couldn't make sense of human language because they couldn't hold on to a thought for more than a few seconds. Okay, so imagine trying to read a whole book, but you can only see one single word at a time, and you've got to remember the entire plot as you go. Sounds impossible, right? Well, that's pretty much what these early AI models, called recurrent neural networks, or RNNs, were trying to do. They process language in a straight line, one word after the next. And it kind of worked, but only for really, really short sentences. And here's where it all fell apart. If you gave an RNN a long paragraph, by the time it got to the end, it had completely forgotten what was said at the beginning. This was a huge roadblock, and it has a technical name, the long-range dependency problem. Basically, the AI couldn't connect the dots if they were too far apart. But then, researchers had this incredible breakthrough. They thought, what if, instead of reading one word at a time in a straight line, the AI could just look at the entire sentence all at once? This idea was called attention, and it wasn't just an improvement, it was a total game changer. It was like giving the AI a superpower. And that superpower is called self-attention. What it does is let every single word in a sentence form a direct link to every other word, all at the same time. This way, the AI can instantly see how words relate to each other, even if one's at the beginning and the other's at the very end. So it's less like reading a line and more like seeing a whole spider web of connections in an instant. So how does this actually work under the hood? Well, you can think of it like a little meeting happening inside the sentence. First, a single word acts as the query. It's like that word metaphorically raises its hand and asks the whole room, hey, who here is most relevant to me? So, in response to that question, all the other words hold up their keys. Now, a key is kind of like a name tag that says who the word is and what its job is in the sentence. This lets that original query word scan the room and quickly see which other words are the most important for it to talk to. And finally, once the query word finds the best match using the keys, that other word shares its value, which is its actual meaning, its context, all its juicy information. This info flows back to the original word, giving it a much, much deeper understanding of its role in the sentence. And the craziest part? This whole query key value dance happens for every single word all at the same time. It's massively parallel. Okay, so this is where a cool idea turns into, well, an entire AI brain. This one concept of self-attention became the fundamental building block for what we now know as a large language model, or an LLM. This self-attention mechanism is the engine inside a bigger architecture called the transformer. The original 2017 design had two main parts: an encoder, which was basically built for reading and understanding text, and a decoder, which was built for writing and generating new text. But as it turns out, you don't always need both. Models like the GPT and ChatGPT are actually decoder only. They are total specialists, laser-focused on one simple but unbelievably powerful task: predicting the very next word in a sequence. That's it. They just do that over and over and over again. And that's how a single word becomes a whole story. And this is where things just get wild. Researchers found a surprisingly simple rule. For these models, bigger is better. The more data they were trained on, the more computer power was used, and the more parameters it had — you can think of parameters as the AI's internal knobs for learning — the smarter it became. And not just smarter, but smarter in very predictable ways. This relationship is called a scaling law. For example, one of the key rules of thumb that came out of this is something called the 20x rule. It basically says that to get a really powerful AI, you need to train it on a mind-boggling amount of text, at least 20 times more tokens, which are like little pieces of words, than it has of those learning parameters. And that, right there, is why these models are trained on what is essentially a huge chunk of the entire internet. Okay, so we've got the architecture, the brain, so to speak. But how does an AI actually learn from all that data? It's not just about letting it read randomly. It's a very specific three-step recipe. So step one is pre-training. This is like sending the AI to the biggest library in the universe and telling it to read everything. It learns grammar, facts, reasoning, just the raw patterns of language. Step two is supervised fine-tuning. This is where human teachers step in and show it specific examples of good questions and high-quality answers, teaching it how to be a useful assistant. And finally, step three is preference tuning. Here, humans act like judges, ranking different AI answers to teach it about safety, tone, and what people actually find helpful. Here's a great way to think about it. Training an AI is a lot like becoming a master chef. First, you have to read every cookbook ever written. That's pre-training. Then, you practice specific important recipes over and over. That's fine-tuning. And finally, you have food critics rank your dishes, telling you which one is better, so you can really refine your taste. And that's preference tuning. Now, the difference between step 2 and 3 is really, really important. Fine-tuning teaches the AI what to do by showing it good examples, but preference tuning teaches the AI what not to do. By having a human pick which of two answers is better, it learns what to avoid, and that's absolutely crucial for making the AI safe and aligned with what we actually want it to do. So far, we've pretty much only been talking about words and language. But that core idea of the transformer, that amazing self-attention mechanism, is so powerful and flexible that it's now being used to understand things way beyond text. So, how in the world do you teach a language model to see? Well, it's actually a really clever trick. You basically treat an image like it's a sentence. You slice it up into a grid of little patches, you turn each patch into a token of numbers, just like a piece of a word, and then you just let the self-attention mechanism do its thing. It figures out how all the little patches relate to each other to form a complete picture. And that's the whole idea behind vision transformers. This whole idea of finding patterns in pieces is now leading to a completely new and way faster way for AIs to generate stuff. And it's probably best explained by this fantastic quote from Michelangelo. He believed his sculptures were already hiding inside the block of marble. He just had to chip away the extra bits to reveal it. So, get this. Instead of generating a response one word at a time, these new diffusion models work just like that sculpture. They start with a block of total gibberish, or a sentence, where every single word is masked out. Then, in just a few quick steps, it chisels away all the noise and unmasks the complete, perfect sentence that was hiding underneath it all along. And what's the biggest advantage here? Oh, it's speed. So much speed. Because the AI isn't building the sentence word by word by word, it can generate the whole thing in parallel. This makes it way, way faster for creating long things like blocks of computer code. It's a massive leap from where we started. So there you have it. From a forgetful computer that couldn't even remember the beginning of a sentence, all the way to an AI that can write, code, and even see. The journey of this one core idea has been absolutely incredible. We've built this amazing tool that is just fundamentally good at learning patterns. The only real question left is, what do we teach it to do next?